Hello and welcome to Sunday's edition of Cracking the Cryptic, where I'm preparing today to do battle with one of these behemoths of the Sudoku world. This puzzle is called Beyond. It's by MaizeGator. It has a 100% approval rating on Logic Masters Germany, and it has 5 stars out of 5 for difficulty. So I'm guessing if I can solve it at all, this will be quite a lengthy video. But lots of you have said, well, actually 2 types of recommendations or requests for this one. Recommendations from people who've solved it saying it's fantastic. I snipped some of the comments before I turned on the webcam. Let's have a quick look at some of these. I mean, some of the great and the good of the Sudoku community here. Mad Hut, Agent, James Sinclair, Mixo, Pietato, all saying that this is absolutely stunning. But we've also had a few requests. I think because it's got this incredible rating, it's encouraged quite a few people to have a go at it who haven't quite managed to make it through. So we've had it requested a few times as well. So I hope I will be able to do it. It's got an absolutely brilliant rule set that seems to be combining Sudoku with the wonderful Japanese logic problem Nurikabe, of which I'm a huge fan. So, and in fact, Mark and I, we had a whale of a time streaming Nurikabe World, one of our stream games from a few months ago. So if any of you watched that, you will know the sort of logic we're likely to encounter in this puzzle. And I will read you the rules in a moment or two's time. I don't have too much to tell you today. In fact, I have got one birthday to do. I'll quickly remind you that over on Patreon, the closing date is approaching for our monthly competition, The Labours of Rostam, which has been getting the most incredible plaudits. So you've still got plenty of time. There's 7 puzzles that you have to solve in the hunt if you want to be in with a chance of winning the competition. Competition prize is that you and I will try and solve a Sudoku together. We will video it, so hopefully it will become a video on the channel. So if that might appeal, do try and get your entries to us by the 20th of August. Plenty of time to do it, but you should probably get cracking fairly soon. It's over on Patreon right now anyway. It's a couple of bucks a month if you're not a patron and you'd like to join us there and support the channel. Other than that, what else can I tell you about? Let's say happy birthday to Z. Z, you've turned 22 today. I'm sorry to hear you've not had the best year. So I'm hoping your 23rd year is going to be a doozy. Thank you very much for watching the channel, and I hope, of course, that today is filled with enormous amounts of very, very, very heavily iced chocolate cake. And that's everything. So why don't we have a look at Beyond by MaizeGator, and I will read you the rules to the puzzle. We have got, and there might be a little bit of noise from young people today, by the way, because there is a trampoline war going on outside my window. I cannot do anything about that. The brokering piece in trampoline wars, I have learnt to my cost over time, is a very, very difficult puzzle to solve. Anyway, here we go. Sudoku, we've got to fill... it's normal Sudoku rules. So we've got to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. Then we've got Nurikabe. We've got to shade some cells representing water such that all shaded cells are orthogonally connected, but never cover a 2x2 area fully. So what does that mean? An orthogonal connection, these cells are all orthogonally connected to each other because they all share an edge. You can get from any cell in this blue area to any other blue cell by moving through blue cells that share an edge. If we were to add this to the blue area, it is no longer orthogonally connected because this blue cell here only touches the rest of its blue friends at a point, at this diagonal point. That is not sufficient for an orthogonal connection. And the other thing we mustn't have is this pattern, because that 2x2 is entirely water, and that's too naughty for words. Now, groups of orthogonally connected unshaded cells, so the stuff that isn't the water, form islands. 2 separate islands cannot touch one another orthogonally, but may touch diagonally. So this is going to be quite tricky to do. Let's draw in. Let's draw some water in. And I better try not to make any 2 by 2s. Let's imagine that was a pattern of water, and these were islands. Therefore, you can see I think that has obeyed those rules. These islands are separated, and they do touch each other diagonally, but not orthogonally. So there, I'm saying there are 3 islands: one of size 4, one of size 3, one of size 6. Now, and it might be worth noting, because this sometimes comes up when people question rules about Nurikabe, is although the water can't have any 2 by 2 areas, so in fact that would have to be island as well, and so with this, islands can absolutely, they can be any shape. They could be crazy shapes. You could have half the grid covered in one island. So bear that in mind. Now, the next rule says, maybe I'll leave this here in case it's useful. Digits may not repeat on an island. So those would, well, they already have to. In fact, all of the islands I've drawn couldn't. Let's draw another island. There we go. This is a new island. This island could not have a repeated digit on it. Now, each island contains exactly 1 numbered clue. So I have failed to achieve that for this one. And this numbered clue gives the product of the sum of the digits on the island and the size in terms of the number of cells of the island. E.g., an island filled with 3, 4, 6. Let's put 3. This isn't going to work, is it? 3, 4, 6 would have a 39 clue, not a 90 clue then. So a 3, 4 and 6 would have a 39 clue because there are 3 cells and these 3 digits sum to 13. So 13 times 3 is 39, and that's what the clue should have been for this clue. A question mark, there's a couple of those at least, I've seen 2, may represent any number, not necessarily single digit. Okay, and there's one more rule. It says a cell with arrows, or arrows, may be land or water, and the digit gives the total number of island cells in the indicated directions combined, not including itself. Not all arrows are given. So what is that saying? Let's look at this cell. So this cell is adding how many island cells there are in all of these directions combined. That's actually quite interesting, because presumably that number can't be greater than 9, because you can't put more than 9 into that cell. Anyway, they are all of the rules. So, do have a go. The way to play is to click the link under the video as usual. But now, I get to play. Let's get cracking. Now, the first thing I was going to do here was, I was reading the rules. I noticed it said something about the clues. Each island contains 1 numbered clue. So all of the numbered clues, and that must include the question marks presumably, all of those, which are very symmetrically disposed, they are island cells. So let's make them green, as if because they're very verdant islands. Now, what's the next rule? Digits can't repeat on it. Oh yes, it was this funny rule about the size of the island. So well, none of these are prime, which is a shame. Okay. So for example, a 100 clue the number of cells on that island must divide exactly into 100, mustn't it? So it's going to be 5, for example. Yeah, you could have a 5-cell island where the 5 cells contain digits that sum to 20, and then you would have 20 times 5 equals 100, which gives the clue. So the size of this island is not 2 cells, because you couldn't make 2 digits add up to 50. It's not 3 cells, because 100 is not divisible by 3. 4 would work. this could be a 4. I'm just going to put options in 4, 5. It has to be 6, 7, 8, or 9, and none of 6, 7, 8, and 9 divide and give an integer when you divide them by 100. So I think this is either a 4-cell region or a 5-cell region, and by analogy that must be the same. Now what about 90? We've got two 90 clues. So 90, again, 2 does divide into 90 exactly, but only if those 2 cells then added to 45. And even if they were 8 and 9, they would only add up to 17, which is a much smaller number. So 3 won't work, because the maximum 3 different digits can add up to in Sudoku is 24 if they were 7, 8, 9. So 3 is too small, 4 doesn't divide it, 5 does divide it, 18 would be the total if it's divisible by 5. 6 doesn't feel like, does 6 divide it? Maybe it does. Yeah, 15. Okay. So 5, 6, 7, 8, 9. Oh no, hang on, we've got to be a bit careful here. I've just realised something about this. Because the size of the island... 6 doesn't work. And neither does 9 for the same reason, actually. Because remember, there's this additional criteria which says, so let's say that was the island. We're told that the 6 digits all have to be different. Well, the triangular number for 6, 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. So if this was a 6-size island, its clue would be at least 126, because 21 times 6 is 126, I think, which is much bigger than 90. So I think this might have to be a 5, which would be the same here. Let's just correct all this. Now, is there any possibility I've missed an option there? I could have done. 4 doesn't go. Let me just double check what 100 again. 4 digits summing to 25 is fine, and 5 digits summing to 20 is fine. The triangular number for 5 is 15, so that's very achievable. Right, so we actually know that both of these 90 clues are exactly 5 cells large. And there isn't a wealth of space for them, is there? I tell you, oh no. Well, I mean, here's a very minor point that I'm seeing straight away from that, which is that you couldn't extend the 90 into both of those positions. And that's for Nurikabe reasons. Because if you did, this cell is definitely water, but it could never connect to the rest of the water in the grid, if that was the case, and it's meant to. So I suspect I'm going to actually complete my due diligence on the green islands, but I suspect this might be where we have to start. Let's try 72. So 72. Now 72 you could do in 3 cells, because if it was 7, 8, 9. 7, 8, 9, 24 times 3 is 72. Now 4 is going to be 18, which is fine as well. 6 does divide it, but it's no good. Because 6 times 12 is 72, but can I make 6 different digits sum to only 12? No. Triangular number for 6 again is 21, it's too big. Right, let's try 60. So 60... 60 could be 3 cells, couldn't it? 3 different digits adding to 20, that seems totally reasonable. 4 different digits adding to 15, that seems totally reasonable. 5 different digits adding to 12 won't work. Again, triangular number for 5 is 15, so that doesn't work. So this is 3 or 4. 150. 150? It's like Steve McQueen in The Great Escape, only it was more than 3. Was it 350? I can't remember. 150? What's that then? Well, it's not 3, because you can't make 3 different digits multiply to or add to 50. 5. It might have to be 5. 5 digits adding to 30. Oh no, 6. Oh, bobbins. 6 works as well, I think. 25. Bobbins. Oh, sorry. It's also windy today, so doors are slamming. And the question mark clues we don't know anything about, so they could be enormous. They could be... What would happen if you had a sort of 9-cell region? Using the secret, you'd have 9 times 45, wouldn't you? What's that, 405? Yeah, it feels like it is. I should know that, and it is. Okay. Okay, all right. So let's park the question mark clues. I think we must have to do Nurikabe now, because it feels to me, well, not really the 72, but certainly these regions, the 90 regions. I think we must have to be careful with those. All right, here is something very simple, I think. Can the 100 clue go straight downwards here? I'm going to claim no, because the moment 2 Nurikabe islands touch each other diagonally, these 2 cells have to be water now. And this water has to connect to this water, which means it's got to come down column 9. But this is meant to be a 5-cell region. There's just no space for it. It's going to bump into this region, isn't it? So I think one thing we can say is that that cell is water. And by analogy, that cell is water. There's a lot of symmetry. There's sort of symmetry around the central column. And, okay, these are 4 or 5. So, oh no, I'm wrong actually. I was going to say how could it not go to this cell? But actually, if it did that, maybe it could. It doesn't have to go to that cell. Oh dear. Oh dear. Hang on. What do we do then? What about, let's see what happens if we extend the 90 vertically, because then again I suspect we're trapping. Yeah, that doesn't work, because again I think a bit of Nurikabe experience is really helpful for this puzzle, because you get a sense for where the pressure might be. And I could see if I push this north, because I was going to create water here that had to get out, I was going to put pressure on this region, and it's actually too much pressure, because this needs to be 5 cells large without bumping orthogonally into either of these 2 islands, and it can't get there. There's not enough space. It can be 4 cells, but not 5. So what does that mean? That means this cell is also blue, and by analogy, this cell is blue. Now, I don't really know where to look now. Maybe I should try. Can this go like that? This would then be blue, wouldn't it? This would be blue. Oh, okay, that's very straightforward as well. There's not nearly enough space again. We keep having to be. Let's think about how we could have proved that. Yeah, the moment that's an island and this is blue, you can, because this blue has to get out and come down here, you can see this green area. It can only be a size 3 then. It needs to be a size 5. So what that's telling us actually is interesting. It's not telling us that this isn't green. This could still be green if it connects to this 90. But what it can't be is part of this. And if it can't be part of the 100, which is at least of size 4, then this has to be green, and this has to be green by analogy. And now this cell, which must keep these 2 islands apart, is water, and that water has to escape, so it's got to come down. Oh, this is getting very cool. Yeah. Now look at this. These have to be at least size 4. They could each take these. Well, actually, they can't both take those cells, but either individually could take one of these. They can't both be green because this domino of water never gets out. But one of them could take this cell, but they both have to take those cells in order to be at least of size 4. Now, so this water has to get out, so it's going to go either left or right or both. If it was both, these would both have to extend. And that feels like it might be mathematically difficult. Hang on, what's the size of the 100 region? It depends how big they are. I mean, by the secret, I can see you can't have 2 4-cell regions in row 1. Let me just explain that. The secret is something I share with only my very favourite people. And if you're still watching this video, you're definitely one of my favourite people. The secret of Sudoku is that a complete row of a Sudoku, because of the rules of Sudoku, contains the digits 1 to 9 once each. And if you add the digits 1 to 9, you get 45. So, imagine that these 2 green areas here were 2 4-cell regions in the first row. Then we know that the digits in these 4-cell regions each add up to 25, because 4 times 25 is what's giving us the 100 clue. But we'd have those 8 cells adding up to 50 then, 25 each. But that's impossible because we know the row only adds up to 45. So there has to be some spillage. It's at least one of these regions is coming into row 2. Now what would happen if only one of them went into row 2? Then you'd have, let's say that one was 25. And then this one spilled out. So say it went there. So this would have to be a great big digit, wouldn't it, in order to make sure that this had the lowest possible total. So if that was a 9, this would be 20 as well then. So these would be 11. This would be 25. That's 36. Oh, and that would be a 9, and that's fine. Okay. Okay, so that wasn't an intelligent way to think about things. Although, hang on. Didn't we work out before that we couldn't extend the 100 to here because it trapped the 90 in? I think we did. So whichever one of these does come into row 2, it doesn't come into row 2 in those 2 positions. So it must come into row 2 in one of these 2 positions, and then it will stop. Oh, this is interesting. Yeah, because, sorry, just to recapitulate, what I'm saying is, it's not possible for these 2 green islands here to live their entire lives in row 1, so they have to spill downwards. Now, the only way they can spill downwards into this cell or this cell is if they're 5-cell regions and they're doing something like this. And we've looked at this already. This doesn't work because it puts too much pressure on the 90 clue. The 90 clue here has to be 5 cells large, and there's just nowhere near enough room for it. So the only way of getting the spillage down the grid to happen is for one of these regions to come into one of these 2 cells. And the interesting thing about that is that only one of them can do that. Because otherwise this domino of blue is trapped in. So I'm now going to claim that exactly one of those two cells is green and exactly one of them is blue. Now, I haven't actually done any thinking at all about the arrows now either. What, I can't even remember what the arrows were counting. The arrows, oh, they can be either colour. And the digit gives the total number of island cells in the indicated direction combined. So that one is just counting green in its row. So we might want to think about that one. I mean, most of these look horrendous because, I mean, the things like this, I mean, this must be disambiguating, mustn't it? It's so difficult to know how... Well, and I suppose unless you can assume at some point these are going to be 9s for some reason because they're looking in so many different directions. Yeah, it feels like that one's the most interesting because we actually do know some things about row 1 and it's only looking in one direction, and in fact it's already looking at 6 digits, so this is at least a 6. So it's... Oh, it doesn't count itself? No. So it is either 6 or 7. That's all it can be. So, what does that mean? I don't know. We might be able to prove that this either is or isn't green, mightn't we? I mean, if that's blue, then because we know this has to be at least 4 big, we would know the shape of this region. So these would be 25. This would have to be blue to get this out. So this would be... And they couldn't take that one. So that would be 25. I feel like we've got too many digits in row 1 for this to be blue. Because let me try and explain that and then we'll actually look carefully at it. But what I'm feeling, and this might be wrong, but what I'm feeling is if this is blue, this has to be a 4-cell region which sums to 25. This one, now if this is green, this has to be blue to get this domino out. This has to be at least 4 big, and we know it can't be 5 big because it gives us the 90 problem. So we've got 25 here, plus even if this was 9, this would be 16 here at least, which is 41 plus 6 or 7, and plus this, but we're going way over 45 for the row. That's total nonsense, isn't it? So this digit is green. We know that this digit can't be green, so that's definitely blue. Now, has that helped us or not? That's weird. I don't think that's actually advanced us at all. Rather Bobbins-worthy. I mean, if that's... What do we think? If that's green, that's going to be blue. This is going to be blue. That's going to be green. That's going to be blue. That's the situation that would arise and would be completely forced as well by them making this of green. And then we'd have 25 here. Now, whatever this is, this might be fine. I'm not sure. Oh, hang on. What? No, this is a 20 region. Oh goodness. Oh, hang on. I don't like that. No. No. Wait a moment. Okay, that is... Oh, that's weird. That is weird. I just need to think about this. I'm not sure I trust what I'm about to tell you, but it's so beautiful if it's true. I feel like this must be relevant. That's 7, 13, 20. Oh, it is beautiful. Ah, this is sick and wrong. This is sick and wrong. Why, I hear you ask? Well, watch this. Okay, we have to do a little bit of thinking now about these two digits and how they interact together. So what we've deduced, or what we were able to deduce, is that we've worked out this was green, and then we didn't know which of these was green, and I just thought about this one being green rather than that one, and I'm now claiming this is wrong. Why? Well, this region here, 5 cells, sums to 20. So let's make this digit, hang on, how am I going to do this? I want to make it x. X, there we go. Now, this region sums to 25 because that's a 4-cell region. So here, what we've got in terms of the sum of these cells in the top row is we've got 25 plus 20 minus x, which is 45 minus x. What is the sum overall of row 1? And you're going to tell me, hopefully, Simon, it's 45. That's what you told us. You told us it was the secret. I totally agree. That's exactly what I did say. Well, in order for that to be true, what does this blue cell have to equal? And the answer is x. And that is absolutely impossible. Isn't that brilliant? And not of me, I hasten to add, nothing to do with me. It's absolutely brilliant of MaizeGator. That is quite lovely. Now, okay, let's make sure that we don't get ahead of ourselves then. So we're here, and we've just worked out this cannot be green. This has to be blue. Oh, that's annoying though. Because does that now not tell us what this is? Because couldn't that be? No, this is now green. One of these had to be green. We worked that out because otherwise this has to be green, and we worked out that broke the 90. So that's definitely, whoa, no, that's green. This is therefore blue. And what we've got to do, we've still got to be careful. I mustn't end up in the same problem. Yeah, if I make this green now, I've got the same problem again. Because then I've got this as x. The sum of these together is 45 minus x, and that's going to be x again. So this has to be blue to avoid the problem, and that blue has to get out. Oh, this is how have you found the way to disambiguate this? It's really clever, and I hope it's not now going to break, because that would be sickening. Because now I have got two 25 regions. I've got no 5-cell regions. I think either of these could, in theory, have been 5 cells, but neither of them seems to work if they are. So now I've got 50. Those 8 cells sum to 50, but these cells sum to 45. So this digit has to be big enough. So let's imagine this was a 9, for example. How would that work? Now these add up to 16. Yeah, this has to be really big. It's got to be really big, because this would be 16. This would be 25. That's 41, which means these squares, 2 squares, have to sum up to 4 in order to make the row 1 add up to 45 overall. So this is 9 or 8, because I can't make these add up to less than 3, can I? There's definitely a 1 in one of them, in one of these 2 cells, and they're either a 1-2 pair or a 1-3 pair. And that digit has to go in one of those 2 cells in row 1, because it can't repeat in its own region, and it's not equal to such a small number. So that digit, let's make that A, is in one of those 2 cells. So A is in one of those 3 cells. Ah, but hang on. Do we now know... How does this 90 grow? Yes, that's a good question. Does the 90 take this cell? Let's imagine it didn't. How would this reach size 5 without hitting this one? It couldn't do it. So that cell's definitely green. And now blue, to get itself out, has to take that one. One, two. I think this might have to be green now. If it wasn't again, that could only be 4 cells large. So that's green, that's blue. How does... Yeah, no, I'm wrong. I'm wrong. I was about to say, how does this blue get out? But then I realised it could come down that passageway. It doesn't have to come through that cell, I don't think. Although, here's a very small point. This blue does have to get out to connect to its friends. So it must come into one of those cells, but it can only come into one of them. Because if both of those were blue, that would be a 2 by 2. So those squares are a blue-green. They are one of each. Now, feels like if we knew that was green, that would be blue, that would be green, that would be green. Oh, wait a second, I know what that is now. This is counting green, isn't it? So it's 1, 2. Oh, goodness, no, we don't know. That's so hard. Do we know what this is? 3 or 4? Wow, I don't know. What about this one? Can we say it could go there? It could go here. Isn't it the same point again? How is that one, this one here, blue? If that's blue, how does this get to be size 5? There's absolutely no way it can. So that's definitely green. And this region has to come through here. So exactly one of those is blue. This is sort of the same thing that we've got there. But that could be the 90 region, couldn't it? It doesn't seem, it's weird, it doesn't seem to be as defined as what's going on the right. So what on earth do we do now? I have no idea. I have absolutely no idea. Do we think it's Nurikabe, or do we think there's quite a lot going on in this puzzle? So it could be. Actually, it could be anything. It's probably not Sudoku, is it? That feels the least likely thing. That probably means it is Sudoku. I'm not sure I like this one of each pattern. I almost think I should make those sort of orange or something to indicate the same logic, or purple. So purple means a domino where one is of each colour. So, what does that mean, if anything? I have not got a clue. So I'm sorry. Oh, well, hang on. Hang on, I might have had one idea. I'm just going to replay that in my brain, and then I will. If that's green, oh, that's weird. Why couldn't I see that before? I'm so dense sometimes. Right, this is a cell that's interesting, I think. I don't think that can be green. Let's just get rid of the purple for a moment. If that's green, then obviously it's got to be kept away from the 60 clue, so that's blue. But we said that only one of those was blue. So, well, we've got to stop a 2 by 2. And now my blue has been trapped into the sort of northeast area of the grid. So this is blue, which means that is green. Now this is a size 5 region, so we can just we've actually got this island built now. Both of those are blue to frame it. We still could take that one. What about that one? Yeah, if it comes down there, it would be fine, wouldn't it? I think. So we can get rid of the 5 in this corner of this one. And, well, hang on a moment. Hang on a moment. Oh, this is ridiculously clever. What a beauty. I now know the corner digit, and I think it's a 3. I'm just going to check. Okay, so this is what I'm thinking. We know that those 5 digits sum to 18. 5 times 18 being the 90 we're looking for. Now, how do you get... What digits do you absolutely have to have in 5 different digits that add up to 18? You have to have a 1, because 2, 3, 4, 5, 6 add up to 20. You have to have a 2, because 1, 3, 4, 5, 6 add up to 19. So there is a 1 and there is a 2 in that little pentomino there. But this digit sees all of that pentomino. So if this was a 1, you couldn't make those squares add up to only 18. If this was a 2, you couldn't make only those squares add up to 18. It wouldn't work. That is a 3 in the corner as our first digit. That's 3 in the corner. That's 3 in the spotlight. Losing its origin. One of these was a 1, remember? And now this has to be 9. Because that was the way that we got these two to add up to 4. Now that means that we can take A out of here and put 9 in. And we know those 3 digits add up to 16 without using 1 and 3. Now I was going to say, do they have to have a 2? But they don't actually. I think they could be 4, 5, 7. Maybe if they do have a 2, then it would have to be 2, 6, 8, wouldn't it? No, I'm doing my maths wrong. That's absolute nonsense. No, we need 16. Oh, hang on. No, I'm not doing my maths wrong, am I? No, these would be 16 with a 2, so the other 2 digits would add up to 14 without using 9, so it would be 2, 6, 8. Oh, hang on. I know what that is now. What is that? 1, 2, 3, 4. Oh, that's a 6. Oh, well, that's... Okay. So I'm now going to claim there is not a 2 in here. I'm just going to triple check my maths, but we know those 4 cells add up to 25. That's a 9, so these add up to 16. So if I put a 2 in there, I need 2 digits that add up to 14 that can't use 9 again. So they're not 5, 9, they're not 6, 8. So the 2 is over there. And now we must be able to work out what this is. This is 6, this is 17 and another 8. So this is 2, 8, 9. And we know that's not 9. So this is 4, 5, 7, which I think was one of the options I mentioned earlier. So let's just double check. 18, 25. Yeah, the maths is working. Okay, and 9 is in one of those cells. 9 can't go in a 5-cell sequence that adds up to 18 because the other 4 digits would have to only add up to 9. And 1 plus 2 plus 3 plus 4 is, it's 10. In fact, let's look at this again, because this now, it still can't have 3 in it, so it's totally forced. It's got to be 1, 2, 4, 5, 6. It's the only way you can make it work. This digit's now under all sorts of pressure, you know. 8 is in one of those cells. This digit, which is an arrow digit, now can't be. It's got to be an enormous digit. It can't be any number that lives in this 18 cage. It doesn't look like an 18 cage, but it is. And it can't be 3, and it can't be 9, so it is 7 or 8. And oh, that feels like it must be important. And this is counting green digits, and we've only got 1 so far. So there's at least 6 green digits down this diagonal, which is of length 1, 2, 3, 4, 5, 6, 7. So if this was an 8, every single one of those digits. Oh, that's absolutely ridiculous. Yeah, if this was an 8 in row 2, column 9, I think by counting the greens, we'd have to have greens through all of those would turn green. And I can see that these blues can't connect to the other blues. There's a wall of green, a diagonal wall of green going down the grid. So that's got to be a 7. Which means this is a 7. This is 4, 5. This is so clever. It is so clever. Right, we've now got 4 and 5 in here. And this diagonal is still mostly green. But it's got to be green in a way that doesn't divide the grid. Yeah, look at this. Right. Okay, what we're going to look at is this diagonal. And we can see we've got 6 cells there. 5 of which have to be green. How could it possibly be those 5? It can't. Because again, that's a wall of green. If you look at those cells, you can see they've hypothecated off these 4 blue cells. They can't get out. So this cell is definitely green. And now, of those 5 cells, 4 of those are green. Now, I don't know how to do that. It feels like it might be possible though, doesn't it, to sort of figure something out there. So somewhere, I don't know where, one of these is blue, and it's going to be the conduit between these blues and the rest of the blues in the grid. I mean, if that was blue, or can all those be green? Maybe. If that was blue and all those were green, then blue would be, there would be sort of a passageway of blue down here. This would be blue. This would be blue. Oh, I see. Right, okay. What we might actually have to do now is switch horses a bit. It might be that we have to think about this. If both of those are green, how is that getting enough? Oh, it might not even be what the first thought. The first thought I had was that this might just be trapped. The second thought I've had is it might not be trapped, but it might have to be of size 3 in a way that won't work, because it can't have 7, 8, and 9 in it in the right way. Okay, so I'm going to claim now that there is and this might be wrong, but I think my brain has foreseen a problem with, remember what we're saying? We're saying of these cells here, of these cells on this diagonal, 4 are green. Now, I don't think those 4 can include these 2. Let me explain why. If both of these are green, look what happens to this blue area here. It has to come there like this. But now, this green area, which is at least of size 3, must extend here. That's the first thing. We know that this is now blue to get the blue out. This is not size 3 yet, at least, so it has to take that. And it cannot grow anymore, because it's going to bump into this one. So how is this constituted? It's 3, well, it's 72 divided by 3 is 24. So this is a 7, 8, 9 triple. But these can be neither 7 or 9. These could only be 8 of that, and they can't be double 8. That won't work. So now I'm going to go back to here. I'm going to say these 2 cannot be double green, so those 3 are green, and what? It's one of these. It might even be a problem for that to be green, but that's less clear to me. Let me just mull that for a moment. That might be okay. I think there is some problem here. But now, so if that's green, that's blue, isn't it, on this diagonal? So this would be blue, that would be blue. This would have to grow downwards. I don't know. I can't see the problem with that, actually. So that was, what was that making that one green, wasn't it? So what if I make that one green? Then this would be blue, and that would be green to avoid a 2 by 2. Oh, this might be a problem. This might be a problem, because now this has to be blue. And that's going to run me into the same problem again. Good grief. Okay, yeah, so that's the problem. The problem is making this green now, I think, because it satisfies this clue, but this green cannot be part of this 72 because it is part of the 60 clue. So now this becomes blue, and we run into the same problem again. This has to be at least a 3-cell clue, so it's going to have to curl around like that. It will have to only be a 3-cell clue, and it will be a 7, 8, 9 triple, which breaks. And something was just buzzing at me. Oh, that's fine. That's fine. That is not a problem. That is not a problem. So we've actually now worked out that this is blue, and that's green, and this water up here has to get out here. This green is not big enough yet. It's 3 or 4, isn't it? So it's got to go down again. This blue has to get out. If this was green, this 60 would be of size 5, and that's too big. It's only allowed to be a maximum of 4. And we've done quite well on the east side of the grid, less well on the west side, but we might have a think about the west side story soon. I'm not sure where to look now. These are 1, 2, 6, 8. This one. I mean, again, yeah, maybe the dynamite question I never asked, but perhaps should have done, is what that can't be blue, can it? Because if this is blue, it pushes this, and it forces that pattern, which forces this to be the 7, 8, 9 triple. It's not allowed to be. So that's definitely green. Oh no, this could be green though if that was a 4-celler. Okay. Oh, wait a second. No. if that's green, I've got a wall of green. I've got a great wall of green going down the grid. Remember, I should take my own advice, that the point about this diagonal is such a beautiful clue, is it was providing one cell of relief, allowing the water on the right to flow into the water on the left, and that passage is now exactly there. Now what's going on with this? How does it, if it doesn't take that? Yeah, how does this 72 not take this cell? It can't, because if it doesn't take this cell, it has to grow to here, and it could only be this size, because this now needs to be blue to get the water out, and that gives us the 789 problem again. So the way we deal with that is to say this is definitely, indisputably green, which means it has to be distinct from this one, which is now blue. Now I'm just going to get rid of my purple and think about it separately. Yeah, how does this green, the water get out? It's got to go through there, which means this has to be green. And this is a 4-cell, to avoid a 2x2. And this is actually a 4-cell region now. So this adds up to 18, and we have none of the problems that we had when we were trying to make this 789. But the 90 here now has to take this cell. This has still got to reach size 5, remember. So that's got to be green, that's got to be blue. This blue still has not got out, so it's coming all the way down here. And now we've got a similar shape here to the one we had there. That's got to be blue. We know this is now size 5. We know it's adding up to 18. We know it doesn't have a 6 in it. So, what does that mean? It can't be... it can't be 1, 2... It must have 1, 2, and 3 in it now. This 90 cage. This cage here. As if it was missing 3, it would be 1, 2, 4, 5, 6, and that would be a problem. So it's got 1, 2, and 3 in it, definitely. Could it be missing 4? If it's missing 4, it would be 1, 2, 3, 5, 7. Okay, maybe that's fine. But we have also got one of these green thingies here. So that's counting this digit and anything... so many greens on that diagonal that are possible. It's 1, 2, 3, definitely, and up to 6, but it can't be 6 because it could take 3 more. So it's 3, 4, or 5, this digit. I mean, what on earth is going on here? What's that digit? Hang on, that digit's got 2 arrows, one of which is pointing west. 1, 2, 3, 4. So it can't be 1 or 2. It can't be 4, actually. The reason it can't be 4 is it sees a green here. 1, 2, 3, 4, 5, and anything green there would make this 6. So can all of those be water? Maybe, actually. Maybe it's possible. So that's 5 or 6. This one? 1. Okay, this digit. It could be a 1, I think, if this is the only green cell. But it could be 2, 3, or 4. If all of those were green. I don't know if that's possible or not. At least one of these is blue to get this blue out. And that means that must be blue to get through this sort of Scylla and Charybdis, these cells here. And do we know whether this is... Oh, yeah, yes, we do. Look at... I haven't looked at this at all. These cells here. What would happen if this was a 3-cell region summing... Well, it would then sum to 20, wouldn't it? 3 times 20 is 60. But it can't contain a 9. So these would have to be 5, 7, 8, and they can't be 5, 7, 8 because there's a 5 over here in this putative 18 cage. So this is a 4-cell cage. We can extend it down and seal it off. And now we've got another Scylla and Charybdis here, which have to be sorted out. Avoid having a 2 by 2 here. So that's green. This has to get to a clue. So all of this is force. This is a 5 or a 6. So it's coming here at least. It might come here if this is a 6 clue. And that's another lot of stuff we've just done. Now, did we get this resolved? 1, 2, 3. No. No, we didn't. At all. Oh dear. What about that one? Oh, that's got lots of white cells in it. What about this one? 5 or 6? 1, 2, 3, 4, 5. No, we still know better. We just still don't know. Goodness me. Okay. I'm not sure where to look, I'm afraid. Let me think. Well, okay, well, what do these add up to now? Let's get rid of the 3 or 4. That's no longer useful. These add up to 15. Okay, that's very, very average. 9 has to be in one of those cells. So 9 is down here in column 9. These add up to 18, don't they? That doesn't feel very useful. Golly gosh, I don't know. Can that be a 1-cell region if this was blue? Oh, actually, look, if I double click the blue, we have to connect this blue. So that's this has to, well, those two have to definitely be blue. And this has to get out, which means it must come through, that cell must be blue. So that's blue, avoid a 2 by 2, that becomes green. We can have 2 by 2s in green, so we can't do this cell. This cell is green and has to connect to a clue, so that's green. Is that on a diagonal? No. Oh, but this clue's getting quite punchy now. 1, 2, 3, 4, 5, 6, 7. It can't be bigger than 9 because we're not allowed to repeat digits in clues. In fact, do I not know that digit now? That might be wrong, but I'm just looking at the directions of the arrows. So we've got to pick up that cell, these two, and that one. 1, 2, 3, 4, 5, 6, 7. Can that be a 7? I'm going to double check that, but 1, 2, 3, 4, 5, 6, 7. I think that is a 7. Which means there's a 7 down there, which can't be in the same region as this one, so that's not a 7. This one. We know this one now. It sees 1, 2, 3, 4. 1, 2, 3. I think it's a 4. Is that helpful? Yeah, that's a 4. That's a 5. Now this adds up to, what did we say? Was it 15? So these 3 add up to 11. Now, is that useful? Could they be... Yes, they could. I was going to say, could they be 8, 1, 2? And they absolutely can. That would make that a 1, 2 pair. Oh, bobbins. They've got to have some sort of low digitage in them. There's definitely a 4 over here. They're adding up to 11. So if they had 6 in, they'd have to be 6, 2, 3. I I think there's loads of ways of doing this rather distressingly. What about those cells then? They're 1, 2, 6, 8. I know one of these is 8. This one we can do 1, 2, that's a 3, I think. I'm going to double check it again. 1, 2, yeah, that's counting. So this isn't a 3. Oh, do we know this one? We probably do. 4 or 5? 1, 2, yes, we do, we do. This one is 1, 2, 3, 4. That is a 4. It would be very, very easy to make mistakes with this puzzle as well. I really hope I haven't. Now I've got 4 in this, which I worked out earlier had to have 1, 2 and 3 in it. In fact, I can now see there's a 3 here and a 3 in one of those. So this has got 1, 2, 3 and 4 in it. It must have 8 in it as well, mustn't it? So we might as well fill that in. To get us to 18, it's the only way it can work. And that's not 3. So this digit is now not, well, let's think about what it can be. 5, 7 or 9, I think, are the options. And it's not 9 and it's not 7, so that is 5 by Sudoku. So 5 is in one of those cells. And now we must be able to do more here. 7 in this box is now placed. It's got to go there. And this is 1, 2. This is a 1 or a 2. It can't be 8 or 9. But that's in the water, so it matters a bit less in terms of trying. I suppose it's got to go in one of those cells, so this digit is in one of those 3 positions. But I suspect we've just got to keep persevering with our watery cells. What about that one now? 1, 2, 3, 4, 5. So it depends. It depends. Can they both be water? Absolutely, I think. Here's a slightly odd point, but I'm definitely making it. It's not possible both of those are green, because it would connect this clue with... hang on, I thought there was a clue down here. Is that not... Yeah, in my brain I had that this was a clue, and it is a clue. I just can't see it anymore. Yeah, so they can't make both of these green, because we'd have a massive area that's on one island. So one of those is blue, and it has to connect to the rest of the blue, so that's definitely blue. Or at least one of these is blue. I should caveat what I was saying. Now 1, 2, 3, 4, 5, 6, 7. So again, it's not possible, is it, that all of these are green? They would be a 10-cell island. So there's at least one blue in this panoply. Maybe it's this one. Let's have a look at this one. Maybe this has got to be 9 or something. So north and south we see 1, 2, 3, 4, 5, 6, 7. So it's at least 7, and it's not 7 because we've already got 7 in the region. So it is 8 or 9. It's definitely not 3. It depends whether both of those are green. But one of these at least is green. If... How do we... Well, maybe it's that... I don't think it can be this clue, can it? Although, I say that, it has got quite a lot of digits looking at it in column 1. I better check it. 1... Oh, actually, hang on. Hang on, this clue is weird, because it really doesn't see many greens. 1? Well, possibly 2. It's 1 or 2. And this digit has to appear in the 18 cage, so it's there, which means 8 is now in one of those cells. That... Oh, this is a single digit clue. But do we care? Oh, this is it. It's easy. Where's 9 in column 1? The answer is I don't know, but it's in one of those squares. So this is 8. And now that is not 8. In fact, these are 7 and 9 as a pair, because I haven't put 7 in column 1 either. And this, okay, this is a 7-cell region. But this 8 is telling us that one of these is water. And one of them is land or island. Now, is it obvious which is which? It might well not be. Hang on. Let me just double. Oh, we've done that one. That clue's finished. This clue is not finished. And depends on whether this is green or not. But if this was green, then, because I know one of those two is green, if this was green, that would be the end of the greens that could possibly go in this region. Because it would. This can't be more than a 9-cell region. And it's definitely got 8 cells in it, and it might have a 9th. So how do we determine? How do we do this? I'll tell you something it might be. These 2 digits are quite interesting in the context of this region. Because how would that work? These 2 digits, if this was a 9-cell region, these 2 digits would have to go in that region somewhere. And the only place they could go, because they see so much of it, well, one of them could go there if it was a 7, I suppose. So if that was a 7, it could go there, and then that digit would have to go in one of those 2. Oh, so maybe it's okay, actually. Maybe it's okay. But I feel like there is some geometry to be thought through there. Ah, okay. So where do you think? Oh, is it this one? What was this? Okay, if this was 5, this would add up to 30, which is a very meaningless number. Actually, even if this is 6 and it's 25, it's pretty meaningless. Maybe it... No, I think it can. Oh, okay. I was going to say maybe it can't have 9 in it if it's a 6, but I think it might be able to. If it grows again and that's green, both of those are then blue, which would... Actually, can we do this a different way? What would happen if... Maybe I can think about this cell even. If that cell is... Which way round we want it to be? If that cell is green, that cannot be true. Now, that might not be true. I'm going to claim that's true. And here's my rationale for that. It's to do with these 2 digits again. Because I now think that this clue has to connect to this green region to create what would be a 9-cell region. So one of these would be green. And let's just make it that one for the sake of exposition. Now, it is absolutely necessary that every digit in the puzzle appears in this region. So where would these 2 go in it? That one could be a 7 and go there, but that one cannot go anywhere in it. So it would be a 10th digit in the puzzle. And it wouldn't matter if we'd made that one the connector, it would be the same logic. So actually, this is blue, and now, by 2 by 2 logic, this is green, and now that is 2, and that is 2, and that is 1, and something was buzzing at me there. Is that a problem? A little bit. Never mind. I have to keep going. there might be trouble ahead. So this was a 2. So if that was blue, it would have to go. Well, it might have to go in this if this was a 9-cell region. But this is now an 8-cell region. And we got a little... look, we got a 2 here, so maybe Sudoku can come to our rescue. I've got a 1-6 pair here, so this becomes a 5. Oh, come on. You are kidding me. Because this 5 now, 1, 2, 3, 4, 5, makes... Let me double check this square blue, because it's already core 8. So, oh, actually maybe that hasn't helped me. Wow, because I think we've still got an ambiguity. That's truly surprising. I've probably just missed an arrow somewhere. Which is slightly discombobulating, but let's keep going with Sudoku for a few moments at least. These squares are 3, 5, and 8. That's good. That's good. 3, 5, and 8, isn't it? Because that's fixing this cell as 2, 9, 8. These squares don't include 6, so we actually know what these are as well. These are 4 and 6. It's remarkable actually, because even with all of the progress we've made, which is considerable, still, hang on, I might just have to send a text message. I'm afraid. Just give me 1 second to write. Yes, that's good. Now I can hopefully concentrate again. 7 is in one of these 2 cells. 2 is in one of those cells. And hang on a moment. Do we need a 1 in there? Because we haven't got 2, 4, or 5, and didn't these have to add up to 11? Or I might have invented that. These add up to 15, yeah. So these add up to 11, but they don't involve 2, 4, or 5. Well, surely, actually, they've got to involve 1 and 3 and 7. I'm going to claim that might be wrong. How else could we do it? If they don't have 1 in them, they're far too many. If they don't have 3 in them, they're still far too many. So they have 1 and 3 in them, and then the balancing digit to get us where we need to be. So this is 1, 3, 7. So these digits are now known in box 6. And they are 6, 8, 9, which corrects some stuff at the top, look. So that's now 8. This is now 2. This column needs a 2 and a 6. And we know the order from this clue. Okay, that's quite exciting. These squares are 3, 5, 7. These squares are something. What do we need? 1, 8, 9. And do we have to be careful with this total? Maybe not. It depends, doesn't it? That's not 8 actually. So there's definitely an 8 in this 150 clue, as well as a 6. We might be able to disprove, or well, we might not as well. Or maybe we can disprove this being green now. These can't both be blue, can they? And whichever one... Or is it possible they're both... No, they can't both be green either, because that will isolate this. So exactly one of these is blue, and one is green. And we're either creating a 9-cell region here, or we're creating a 6-cell region here. And if this was a 6-cell region, it has to add up to 25. And it would have 2 digits in it that were 8 and 6. So the other 4 digits would have to add up to 11. And they would have to be 1, 2, 3, 5. And rather where would the 2 go in that region? Where would the 2 go in that region? That might be it. Okay, let's double check the logic there. So what I'm saying is, I'm going to extend this and make it green. And now I'm going to recompute this. It's a 6-cell region. So the digits in it sum to 25. It's got 8 in it. It's got 6 in it. So the other 4 cells do add up to 11. Therefore, there are 1, 2, 3, 5, and I can't put 2 in it, so it is wrong. So this cell is blue. This cell is green. It's not 7 then, because we've already had 7 in this region. So that's 7. That's not 7. This is now blue, because this region cannot get any larger. It's already 9 cells large. And now... well, now these 2 digits are in play, aren't they? Those digits, which can't be any of those 5 or those 2, have to be those digits. It makes me very sure this has got to be 7, but maybe that's wrong. Maybe it could be 9. No, because if one of them has to be that digit. They are those 2 digits, aren't they? And this cannot be 7 because that is a 7-9 pair. So that is 7. That is 9. That is 7 now in box 9. This 9 is coming out of this cell. And this, so we can get rid of the orangification. These 2 digits are the same. Which, well... Actually, we should actually just be diligent about that. What are the options? So in theory, 1, 4, 5, 6. Not 3 apparently. So not 4, because 4 sees this one. 1, 5, 6. And that's 1, 5, 6 as well then. It's not as good as I hoped, but it's not terrible. It was worth doing, probably. It probably just about merits that description. Oh, wait a moment. I've not thought about that for some time either. Can we do anything with that? What do they add up to? 18. These 4. Ooh, so... well, I don't... it doesn't feel like we're miles away. If there was 8, 5 in there, 13, these would add up to 5. That does look possible, doesn't it? Okay, so I've got to find somewhere. Oh, maybe this 150 now? This is 5 cells, so these are adding up to 30. And we know we've got 8 in there. And we know we've got 6. So the only place we could put 9 would be the corner. And if we didn't have 9, this would be 15. These 2 digits would have to add up to 15, and they can't. So we do need a 9 in there. So what I'm saying is, if this isn't 9, this is a 1-8 pair, plus 6 is 15. We know this is meant to add up to 30, so those 2 have to add up to 15, and this is too small. So this is an 8-9 pair, and that is a 1. And the only place 9 can go is here, so we get this pattern emerging. I still think we can do a bit better though, because now, oh yeah, look, this can't be 8 or it would repeat in its region. But we now know we've got 23, so these squares add up to 7. So this is 2 or 4, and it can't be 2. So that's 4, that's 3, that's 5, that's 3 apparently. And now in the bottom row, what have we not had? 1, 5. And then if we haven't had 1, 5, which I hope is true, not only can I put that in, but that makes that 6 and that 6. And now this digit is a 4. And now in this column we need 5, 7, 9. In these positions, let's just get rid of some of our pencil marks. We need 4, 6. Oh, 2, 4, 6. Okay, 2, 4, 6. This extra region of the puzzle has not had 2 and 9 in it, and they can be placed 2 and 9. So 9 is in one of those two cells. I'm not sure if it can go into that 18 cage. These cells need, well, there has to be a 3 in here and a 1, 5 pair, which we can place. So this is 3 at the top of the column. And this 6 is lovely. I haven't seen it, but it's doing great things. This column needs 4 and 9 into those squares. Oh, this became a 3 now. That's slightly discombobulating. We probably just have to pencil mark this digit, I would think. That can't be 7. Let's just double click all of the green cells. We have got, or let's double click the blue. Yeah, we've got, lovely. The blue looks right, doesn't it? In the sense that it's orthogonally connected. I'm not seeing any 2 by 2s. Okay, and we know those 3 add up to 15. And this digit is 1, 3, 5 or 8. And it can't be 3, so it's 1, 5 or 8. It can't be 3 because 3's already appeared. So if it was 1, oh, that could work. It could be 5, 9. If this is 8, 8 and 5 is 13, 16, that wouldn't work. Yeah, this can't be a 5, 8 pair. Because we've got 16 in those cells, this would need to be a 2. So the only way of avoiding a 5, 8 pair is making this a 1. And now these do have to add up to 14. And I think the only way of doing it is 5 and 9. And that gives us a few more digits to play with. Here we need 2, 5, 6. And that's not 5. And here we need 3 and 8. So the Sudoku is all working. And that gives me some confidence. We're not a million miles away here from working this out. That's 4 now. Which seems to mean this has to be 6. That has to be 2. There's all sorts of Sudoku going on. I feel like I'm doing this in the most inefficient way ever, but never mind. Let's just concentrate on not making errors. 3, 1, 7. That seems to have to be a 1 now. This is an 8. This is a 3. That's 3. That's 8. So that should be 8. This is now 6. This is 9. This is 2 apparently. 2, 5, 6. 9, 5. Possibly done. Possibly done, yes. That is a splendid puzzle. That is it's taken me an hour and a half, but my goodness me, what a great puzzle. We went to the back end of Beyond to solve it, MaizeGator. But that, yeah, I mean, if I'd have been rating that, I would have given it 100% without equivocation. It is lovely. The logic at the start is weird, but it does allow you to make progress. And then my favourite bit was the 3 in the corner. The fact that was forced to be an island, and I worked out it had to have a 1 and a 2 in it, and it forced that digit. It was so pretty, and then everything started to flow from there. It's a superb puzzle, it really is. Goodness me. Let me know in the comments how you got on with it. I enjoy the comments, especially when they're kind. MaizeGator, take a bow, and we'll be back later with another edition of Cracking the Cryptic.